Hi, this is Nick. I thought I would do another little demo of this app. For one thing, the last one was a week ago, so it's really out of date. In a couple ways, the app itself has new things in it as well. That perhaps most notably, I made it so you can split apart provinces and states and treat them as whole countries. So you can chart New York State against Italy and throw in different combinations. So what is this? Actually, let's switch this back to linear axis for the moment, even though it's by far the worst way to look at it. We're going to do everything wrong. X-axis here is time. You've probably seen one of these by now. The x-axis is number of days, but normalized to start at each country's, the day that each country had a 10th person pass away. We can change that 10th to 30th or whatever. We can change death to confirmed case. This right now is only showing 4 US states against various countries across the world. I'm going to show a number of charts. This is only the first. And I said this is a normal y-axis, and we'll come back to the other one in a second, but let's stay on this bad one first for a while. Note that Spain and Italy, this is Spain's track here, cumulative deaths over time. This is Italy's. For the last week or so, they are kind of our leaders here, for lack of a better word. They're remarkably straight lines on this linear axis chart. So about 700 or 900 people are dying every day there. And that number of people dying per day is not changing a lot. How long will it go on that they're in this sort of linear phase? We don't know. But at least they're out of the exponential phase. This was when they were in an exponential phase down here. It's very hard to see really anything on this chart. In fact, I'm going to add every other country and state in the world, or at least everyone that's in this data set. This is, by the way, the Johns Hopkins University CSSE groups data set. You can see the chart is largely the same, except that the framework gave up trying to draw a legend for 223 lines. There are 223 lines in here. They're just all squeezed down here at the bottom. Note, secondly, we have really left China's Hubei province behind. It is here. In case you missed that, that was a while ago, but we're really well outside of the bounds of that. Also note, New York State is way down here. It looks small on this chart. Remember, I've said like 5 times, this is a terrible chart. This is a terrible way to visualize this data. It is, for one thing, really more about the doubling time than it is about the raw numbers. And this is also the chart of cumulative deaths, and the number of deaths lags behind the number of confirmed cases. Let's briefly switch over to confirmed cases. Actually, let's switch to remaining patients diagnosed or testing positive. Now, same color. It's the same. The U.S. New York is now at the top. It's hard to tell on this line whether New York State's line is still on an exponential curve or whether it has become linear. Your eye might sort of want to tell you that it's becoming more of a line. Our eyes are really bad at recognizing exponential curves, and it's not. So let's go back to cumulative deaths for a moment. Let's just say thought experiment that, let's say New York State and let's say New Jersey as well, which is not far behind, switch tomorrow from exponential growth to where they're in exponential growth now, where the doubling time is slowly lengthening, and lengthening is good because that means you're at least approaching the change. But instead, say tomorrow they switch to purely linear growth. If Italy and Spain are the guides of that growth, then it's going to be a long, painful phase. Okay, finally, we can get away from linear axis. I just wanted to show all the bad things about linear axes. I'm going to show the exact same chart, but switching the y-axis to a logarithmic scale. And it looks totally different. I'm sorry, this is like high school math, but I'm going slow. We're still charting total cumulative deaths over time by the number of days since the 10th death. The points are the same. The y-axis is different. So points on this chart, if they're making a straight line that goes up and to the right, as for example Spain's lines were here, if these points were making a straight line, that means it's in an exponential growth phase. It's doubling. this is 1,000, and it doubles when it gets to about here. I don't know if you can see these grid lines on the video, but this second grid line is 2,000. One grid line up is 5,000. Again, one up is 10,000. One up is 20,000, so on and so forth. So this is every country in the Johns Hopkins data set, and every state in the US, and every province in Canada, and every, like, as much as there is, as much detail as there is in there. Broken out, each is a separate line, and there's 223 lines. This is kind of the whole life cycle here. Wherever the lines go straight and flat at the end, where they go horizontal, that means that people stop dying. The deaths no longer went up. They stayed exactly where they were. Note, your eye may have told you that there aren't a lot of examples here of the lines crossing each other. There are some examples. Lines just kind of lines busting out of their lane and crossing over, but they do kind of follow this spray pattern. So let's investigate that and see whether it's true. Let's remove all the ones for whom the 10th death was a long time ago. So I'm going to actually remove, this feels very wrong, but I'm going to remove all the ones that have had lots of articles written about them. All of China. I really should have prepared this and not had all this clicking on the video, but live and learn. Still have to fix this bug. These are France provinces, but it's like Réunion and stuff like that, so they're rather small. Not Georgia. Oh, that's Georgia, the country. Anyway, we'll leave them on there. What I'm removing is the ones for whom they're furthest to the right, and it's going to allow us to basically zoom in on the remaining points. It doesn't really change the chart. It just kind of makes it easier to zoom in on the left side. And let's remove Washington State, I think. Good Lord, that's a lot. So again, we just took away the longer ones and zoomed in on what was left. Still see it's pretty rare for these lines to cross each other. They're making a little floral spray pattern. The steeper lines are bad. Those are shorter doubling times of about 3 days. You can see that quite clearly. New York's numbers of deaths doubled in about 3 days here. The shallower lines at the bottom are much better. Longer doubling times, roughly 7 days. This is the country San Marino, which is actually sort of embedded in Italy, which is neat that it's so small, but it's a smaller numbers. Likewise, a lot of countries are down here with much longer doubling times, but there's a press of them in here as well. Again, there's 179 lines on this chart. You can't see them all because they're covering each other up. So we could put Italy back. Let's put our Italy back as a sort of, well, certainly not a good case scenario, a bad case scenario. And if you're below, you'll probably stay below, and if you're above, you'll probably stay above, and you'll chart out this progress. I'm going to switch to a completely different metric of case fatality rate. There's lots of stuff you can chart in here. There's another data set from a different website that does US testing data. I don't know if it's the Johns Hopkins data is far more useful. This, however, is case fatality rate, which is a very simple statistic. It is what it is. You take the total number of people who are known to have died from the disease and divide by the number of confirmed cases of the disease. In this case, we do that in every province, in every state, in every country. This charts that with the then current values for each day. So you can see case fatality rate changing over time. Why am I doing this? Because it starts out, for some countries, it starts out very low, and then it rises. If you look at New York, actually that's Switzerland. New York also started pretty low and eventually rose to 2.8. And some countries, some provinces start very high and then go down. There's also some runaways here. I think this is not an official interpretation, but I believe when you get to a certain point, they start counting the deaths a lot more accurately than they count the total cases. And so this sort of throws off the ratio if only one of the numbers is really accurate. And the actual confirmed cases are people just staying at home, not even going to the hospital. Then this creeps up a lot. But maybe I'm wrong. Maybe there really is a 12% death rate, 12%. Anyway, case fatality rate, like I said, it is what it is. It's based on known numbers, and so this is the case fatality rate of Italy. So forget for a second, I just wanted to show this because there's been so many long discussions about what the real incidence is, the lag in testing, the pending tests, the systematic under-testing. If you take all that away, all these countries and states over time, they're trending to a case fatality rate that's in a band. And it's not down here. No one's down here. They're all between 2 and bad numbers. Okay, I'm going to go back to, actually, let's go back to everybody. Cumulative deaths, log axis. The spray, where this is the whole life cycle of, geez, there's a lot of points in here, look at that. The whole life cycle of everything. The lines do eventually go flat. They flatten and then they become flat. People stop dying. There's evidence that the doubling times of the US states are getting longer as the weeks go by. Let's look at US again. I don't think it's fair to say any, well, it's not really fair to say any US state is in a linear track yet. If we put these on a linear y-axis and we look at them one by one, none of these are making what you would really call straight lines. You know, if you look at more than a few data points. The bad news is that if Italy and Spain are the guides here, then after the acceleration stops, there's still a long and very, very painful linear phase where large numbers of people are dying every day. There was some boring stuff that I deliberately put to the end. The app is, of course, free. It requires 2 other apps from Splunk base, but you can download them for free as well. If you are a Splunk person, like if you have a Splunk Enterprise instance, you can put apps on. There's no real reason not to install this app on it. I can't think of any. It doesn't index any data. It doesn't require any setup at all. Once it's installed, it's all ready to go. You usually have to update it every day to get the new data. A snapshot of the data is actually in the app, so you really should try and update it every day. It's easy though. It's a dead simple app. It only lives on the search head. Doesn't even index any data. Who am I? My name's Nick Mealy. I'm a Splunk expert. I've been a full-time Splunk app developer for as long as the product has existed, the Splunk product. Because, for one thing, I used to work there, and I'm one of the original engineers that built it. My particular area is user interface and data visualization and data exploration interfaces. Wow, this is really boring. At least I'm not some crazy person who decided this was the year they would start playing with visualizing things. It's really weird to use Splunk for this. I know that. Splunk is a big data product, and this data set is inconceivably tiny in Splunk terms. It's important, but it's not actually a lot of data. I'm positive there are many other platforms that are better suited to this kind of analysis, even ones that you can iterate on quite rapidly. But I'm no good at building things in those ones, and I'm good at this one. I'm sure I messed something up. Please leave a comment, or if history is any judge, I'll think of the thing I messed up after I post it, and then I'll add it as a comment myself. Thank you for watching. And I hope that if there isn't a better one than this out there already, I hope you install this one.